in from 2, 4, or 5. So I won't be able to capture the map. Okay? Alright.
Can you see our screen?
Can you see the screen? Can I give you a screen without uploading the map? That's the question. Yes. Can I give you the screen without uploading the map? So I need to finish uploading all the map before. And I just tell you now that it will be ready by noon because of the load shedding. I already finished marking everything, so just uploading the map. That's but during the evening, I'm not sure I will be able to do that. So by tomorrow noon, all the map will be ready, and then you need to access your map with this thing. Okay? Good. So let's continue. We will to discuss on everything in chapter 2 and 3. Okay, so now we're about to start a new chapter, which is chapter 4, about the manual theory. Okay? Okay? So, please pay attention very carefully because we're going to go pretty fast in this chapter. So the goal of this chapter is to help you to do certain kind of operation and easily. So if you have two numbers or two arbitrary numbers that you want to add them, you don't know the value, but you want to add them and raise to a certain power. Suppose now that I give you square root of 2. No, suppose I give you 2 plus 3. 2 plus 3, and I ask you to raise to the power 100. It's easy. This is easy because 2 plus 3 is 5. I can raise easily 5 to the power 100. Yeah. But now, it may become, because you can add directly 2 plus 3, which is 5. You can know directly 2 plus 3 is 5, and then you raise to the power 100. But what happens if I now change? I mean, square root of 2 plus 3 now. So, you see now that square root of 2 and 3, they are all real numbers, but they are not of the same nature. They are of different kind. Because square root of 2 is irrational, and 3 is a rational number. So they are different kinds. So raising them to a power, maybe a certain power 100, require some extra work. So I cannot add them directly, like this one. Like this example, I cannot add them directly. So what are we going to do now in order to know the answer of this square root of 2 plus 3? Raised to power 100. But in general, what's happening in general, if I have x plus y raised to the power 100, how am I going to evaluate it so quickly? That's what you want to answer now. And put it on silence. Just switch off. Switch it off. You don't know how to switch off your phone. I can show you. Okay. So imagine I want to raise by 100. But okay, some of you, those who are smart, they will say, okay, if I want to bring x plus y to the power 100, and so far I could use my brain to the let me first of all do x plus y squared, because you know how to do this kind of thing. S plus y squared, you know the answer, right? You know the answer now. What's the answer? S plus 2sy plus y squared, you know the answer. Yeah, actually, yeah. How many times I'm also sure? Please don't disrupt the class. Eh? Don't disrupt the class. Don't disrupt the class. You see now when I give this now, I'm lost. Okay, I can't remember what I just said now. Okay, okay. So you should understand the goal of this chapter. Okay, the goal of this chapter is actually to add. It could be addition or subtraction, plus or minus of two arbitrary number raised to a certain power. How are you going to calculate it easily? That's the goal of this chapter. Okay? Yeah. So I think we all know the goal. So at the end of this chapter, you should be able to know how to do this kind of calculation. Okay? Now, let's play a bit. If I give you, you say x plus y squared. It's equal to x squared plus 2xy plus y squared. Okay? That's what you know, right? Okay, good. What's happened if I want to know x plus y is power 3? What will be the answer? Do you know in your head? Huh? Okay, if you know in your head, give me. Okay? That's good. So the same, if I'm doing this, the same will apply to minus. Okay, if I have minus here, you know that you have the same, you have minus somewhere. Okay? Okay, good. So what's now if I ask you to do this, yeah, can you give me the answer now? For those who were sleeping before. S4. What place? Continue. Continue. You don't know the remaining. You don't know the remaining now.
4x.
Okay. Plus 4. Okay, plus 4x.
X cubed y.
Plus 6. Be faster. Faster. Okay. So you see now that the speed on which you were giving me this one it increased now. Because we started going a bit high and increasing the order. So if I increase a bit now to power 5, then okay, let's do that's become a more challenging. Yeah. So you see now? So let's continue with hundreds, now 1,000. That's the challenge to increase. Okay? But there is already a result that have been proven that we can use easily to know actually what are all the terms that will be part of this calculation. Okay? Yes, if I give you this, you could figure out it by yourself. Because you know that x plus y to the power 4 is equal to s plus y squared multiplied by s plus y squared. But you know already this, which will give you s squared plus 2 1s plus y squared multiplied by s squared plus 2y x plus y squared. And then you start developing the term. You will do it. Yeah. And maybe for this one now, this one will be x plus y squared multiplied by x plus y to the power 3. Okay? And you know already x plus y squared, and you know x plus y cubic, and then you just multiply them. Yeah. So if it is s plus y 6, it is really continue the same thing. But now we want to do the engineering formula. How to quickly write it there. Okay? So if you develop this one now, This will be the first step. This will be the second step. This will be the third step, and then this will be the fourth step. Okay? So, in modular setting, we will write the formula. We will not prove it, but the proof is easy. So, with this formula now, you need to know what are the steps for if you want to raise a given, okay, so this being said, there is a tool that is used in combinatories. Combinatories, yeah, good Bible. Good Bible. There's a tool called Factorial in combinatory or probability that you will probably see next semester. I'm not so sure if you are doing probability now or I'm not so sure. So, if you want to, you have a give you an example. You have two cases now, and then if you want to know, let's say I have 2, 1, 3. They are buying three places. I want to know the different way, the different number of ways I can arrange 2, 1, 3. 3 factorial. You know it before. Okay, good. So it's permutation actually. It's permutation. So what are the different ways that I can do to get 3, 1, 2, 1, 3? So actually, I have 3 factorial way. You know it before? Oh, oops. I think that's the first. Okay. So that means if I have n things and I want to know the different way of permuting them, it's just n factorial. Okay? Yeah? And you know the expression of n factorial there? Or factorial n. Let n be in natural integers. Okay? N factorial is n multiplied by n minus 1 multiplied by n minus 2 up to 2 multiplied by 1. Okay? You know it before? Yes? Good. But you are saying yes now. A lot of you are saying yes. Okay. So you should just know that actually n factorial here is just the number of ways that you can permute n number, n distance, n entity. Okay? So suppose that I have 3 students and I have from the 7, 9, they have 3 them. I make them, they cannot be the same. They are all distance. Okay? And I see that you see this is your first seat, second seat, and the third seat. I want to know the number of ways I can do to permute them. And each of them will change in different seats. Okay? So maybe you can sit here, you can sit and she remain there, or we exchange. How many different ways can we do that? It's just 3 factorial. 3 factorial, and that's all. And 3 factorial, there's you have this on your calculator. It's just 3 times 2 times 1. That's the formula. So it's 6. Okay? So in general, if you have n factorial, if you want to compute it, is n times n minus 1 times n minus 2 times 1. Okay? So let's compute 7 factorial. Factorial 7 is 7 times 6 times what? 5 times 4 times 3 times 1. That's all. That's how you compute factorial. Okay? Yeah? Do that. So you can all compute factorial of an integer now. It's just the formula, just apply it. Okay? Good. Now, there's also another tool in combinatories.
Question.
So,
Yeah.
why is 0 factorial regarded?
Factor of 3 is 1.
times one is
Sorry?
why is it one?
By convention.
By
By convention.
convention.
Yeah. We argue in math community that we use biology to be one. It's axiom. You know what's axiom. You cannot prove it. You just think it like that. That's what we saw in answer. What's the definition of axiom? It's a property that do not have a proof. We cannot prove it, but we assume to be true. That's axiom. Okay? So just agree with me that 0 will be always 1. Okay? Okay? Did that answer the question? Okay. So there's another tool in combinatorics. What's the combinatorics? Is just calculating different way of counting some sets or counting some elements. So imagine that you have 3 boards or maybe 3 books that are distant. Let's say book 1, 2, 3. So I want to know how many ways I can choose 2 out of 3. I have 3 books in this box now, and I want to know the number of ways that I can choose 2 out of 3. How I can know a different way to do that? I have 3 books in my box. Distance book, I can okay, let's say distance. 1 red book, 1 blue book, and then 1 yellow book. So they are all distance. But I want to choose 2 out of 3. So if I want to choose 2 out of 3, what are the different ways to do that? Yeah. See? Sorry? No. Okay. So that's the answer is actually a binomial coefficient. It's in combinatorics that you find those in combinatorics. Okay. So if you have, suppose that you have n objects, n distinct objects, and you want to choose k objects out of those n. What are the different ways to do that? It's called it's just the binomial coefficients. Okay. So in general now, actually here now we want to choose 2 out of 3. And in general, we have n objects. In general, we have n objects. And we want to choose n distant objects. Let's say distant objects. Okay? Distant objects. And we want to choose k out of the n, where k is less equal to n. Because if you have n objects, you cannot choose more than the n. Right? You can only choose less than the n. Yes? Right? If you have 5 objects, you can choose 7 out of 5. Is it possible? Okay. So that's something that if this term is called the combinatorics, the binomial coefficients. So the notation is we do it like this: 3, 2. And sometimes you will see it in other book, they wrote it like this. Yeah. In some book, they wrote it like this. It's just telling you the number of ways to choose 2 objects out of 3. How many ways? Distance. Increase. Distance. Distance. Okay? Because, look, you could have a set of objects that have actually some elements that are the same. But what we are basically doing is that all all the elements of our set are all distant. Okay? Good. So this is called binomial coefficient. And in general, we have n objects, and then we want to choose k out of n. So this is how I write it. It says k choose n. Okay? And or you could write it with this notation. You could write it with this notation. Are you following? Hmm? Just follow me here. Because the general formula that I'm going to give now we will use all those things that I'm saying now. Okay? So how to calculate n choose k? K choose n. How to compute k choose n? That's what I want to give you now. The formula is, sorry, this is n, is factorial n, a factorial n minus a factorial. That's the formula. Okay? I hope you're following. So we already know how to compute factorial n. We can compute factorial k. We can compute factorial n minus a. If those values are given. Okay, let's try to compute. From the example that I gave, actually I have 3 books. And I want to know how many ways that I can choose 2 out of the 3. And you know, the answer that it is 3. Okay, so this is the binomial coefficient. And if I want to use the general formula, this is equal to what? Yeah? Divided by what? Times 3 minus 2. Yeah, it's 3, yeah? Alright. So, factorial 3 is what? 6, right? And factorial 2 is what? 2. And factorial 1 is what? So it's equal to 3. So how many ways? Now it's 3 ways that you want to choose 2 books out of 3. Do you understand? Yeah? Do you understand? Okay. So in general, this is how you compute it. If I give you any, you can compute now any by your coefficient now. Just read the formula. You can compute any. Yes? So if I ask you to compute 10, 7, 27, you know how to compute it then? Yes? Are you following? Okay? Yeah. What's the answer? Yeah, what's the answer? Yeah, you. No. Yes. Okay? And on your calculator, you have a factorial there. It can give you the answer quickly when you have a big number. Okay? You can do it quickly here. Alright. And I think on your calculator, you should have also this binomial coefficient. But just be careful because then on your calculator, you have 2 terms like this. There's what we call arrangement. So just be careful if you are using the calculator. I think they have a kind of notation like this in the calculator. I'm not so sure. Sometimes they have this. But this is not what we are dealing with. This is different. Two different things. Okay? No, so you and I see your yes, so now yeah, I'm just going to can you see? Can you see? Can you see? So here now you see NCR. That's what we are basically talking now. NCR. Now you see. That's alright. But you will see somewhere there now it's an NPR. That's different, completely different. So don't do this one. This is very different. Okay, just to check. You can use actually the calculator to give you directly the answer. But just be sure that you are using the right binomial function. Okay? That's I think can I see another calculator. The same thing, another something. Another. Okay, that's all. Okay. So far, we are on the same page, yeah? Are we on the same page? Okay. All right. So now, I'm going to write down a formula. Okay? But please, don't be afraid of the formula. It should not scare you. This should not scare you at the first sight. Okay? But just basic things. So, x plus y raised to power n is just a summation of k from 0 up to n, n is k, s n minus k, y k. Huh? Is it now? Very, very simple. Huh? What? It's scary, okay? No. So, look, are you familiar with these summations symbol? Sigma 3. You familiar with that? Okay, this way to write it a compact way. Okay, so that's the binomial theorem. We will not be going to prove it. Okay? But you can see from this expression, you have what? Already the binomial coefficients, which one we just discussed now. N, K choose N, K choose N, K choose N. So for each term, we're going to know what are the binomial coefficients corresponding. Okay, if I want to expand this now, this will be, look, the summation is from 0 up to n. Huh? We are summing from 0 to n. So that's something that I need to do for k equal to 0, k equal to 1, k equal to 3, k equal to 4, k equal to 5, up to k equal to n. Okay? So for k equal to 0, I just need to plug 0 there. So I'm going to have what? N to 0, right? X to power n, y to power, yeah? That's the first step. Okay? The second term, k equal to 1. So it is n 1, x n minus 1, y 1. So actually, it is k that is varying now. The value of k is k. So it's moving from 0 up to n. So for the first term, k equal to 0. For the second term, k equal to 1. For the third, and so on. Okay? Alright, the second term now is what? N2 x n minus 2 y squared. Okay? Yeah? The third will be what? I mean, the fourth will be n3 x n minus 3 y n, right? X to power what? N minus what? N, y to power what? N. Good. That's the expansion. Okay? Do you understand the expansion? I explained it then. That's the children. Okay, so let's try. Let's go. Good. So let's use this to take what we knew before. What we knew before. You know that x plus y is equal square is equal to s squared plus 2sy plus y squared. So let's use this to confine what we know before. Then you can actually believe this formula, even if you don't agree. You don't see the proof for now. Okay? So let's use it. So here our n is what? If I want to compute x plus 1 squared, my n is 2. So let me just write down the formula. Okay? Just write it. Basically, plug k and then n. Just simple. So it's supposed to be k0n and choose k, right? S n minus k y k, right? So what is fixed here is n. So I just need to replace this n by what? 2. 2. Yeah. Sorry? Why? Why is it like that? People think it's like that. Why is it like that? Yeah, because we are just computing a number. If you were asking me this why, here in this formula now, I would understand. Because if you say why, but why this is true, then you are asking the proof. Okay? Yes. So this is the general. But now I am looking for a special case. N equal to 2. Okay? N equal to 2. So n equal to 2. I want to know what is s plus y squared. And confine it with what was known before. You know the answer, but I want to use it in order to develop and then we see whether we can get actually what we know before. Okay? Yes? Okay, good. So I just, k is variable, but n is fixed. So I just replace n by 2, and then I got this. Okay? Let me expand it. The expansion. So k, the first term is what? What's the first term? Yeah, you. The first term. Okay, k, start from 0, right? And what will be the first step? So, first of all, how many terms do I have? Yeah. Okay. Don't answer yet. How many terms do I have there over there? How many terms do I have over there in the general formula? Yeah. Terms. When I say terms, it's considered as one term, the second term, third, fourth, and so on. How many terms do I have here? Is it n? Is it n? Sorry? I'm seeing this. Yeah. Is it n? Is it n? Is it n? You don't know how to count. You cannot count this. You cannot count them. Of course you can. 1 to second term. Up to n. So it's n plus 1. Okay, how many terms should I have here? Huh? 3. Okay, I have 3. I have 3. So if you raise certain things to a power n, you know that you already you will have n plus 1 term. Okay? So the first term is what? Yeah? X to power 2 minus y plus now the second x to power plus good. Yeah. So let's calculate it. Okay, so 2, 0. 2, 0 is 1. Quickly, we can know the answer now quickly. But if you are still struggling, you can just use this formula. Okay? So this is 1. This term is 1. 1. Okay? So 2 minus 0 is so 2 squared. Y raised to power 0 is what? 1. I can just okay? Okay. Plus 2 choose 1 or 1 choose 2? Is what? Huh? Sorry? 2 choose 1, 1 choose 2. The value was 2. Why? Do you calculate it? Or you just give it me like that? Huh? You did it. Yeah. So 2, 1 actually is what? Factorial. Okay? 1 factorial. 2 minus 1 factorial, and then it's 2. Okay? Yes, so this is 2 x 1 y 1. Okay? 2 2. Eh? Calculate it then. Don't just guess. Okay, so it's 1. X 0 y 2. And x 0 is what? Okay, so the final answer is what? S squared plus 2xy plus y squared. And that's what we know. We just from now what we know before. Yeah. It's easy now, right? It's laughing. Why are you laughing? Sorry? Okay, but yeah. Okay, good. Yeah. Pardon? S. Here we have 15. Yeah. Yes. Yes. That's what the formula is. You have 16. Yeah. Yeah, you write it all. You cannot leave one. Yes. It's N. Yeah. You say the first give us pardon? The first thing you give us X plus Y. Yeah. So we have 101 there. You have 101 there. You can write them now, but yeah, sometimes they will ask you if the term is too modern, can you give maybe the fifth term? They would ask you maybe it's a particular term in that expression, maybe in exam or test. I give you this now, S plus 1 to power 15. I ask you, can you write down the fifth term or the tenth? Just give me. Okay? All right. So I guess we all know now how to do this. So how it works. it will work for addition and subtraction. Okay? So if actually I want to rewrite this expression now, this expression and let's rewrite it. For subtraction, if I want to compute x minus y to the power n, you can see it like x plus minus y. So this is actually subtraction, but you can see it as addition, where the two terms are x and minus y. Okay? So if you see it like that, I can just write it. So you can see that x plus minus y to power n. Yes? Yes? Okay, good. So then I will write down. So this is just summation of k from 0 up to n. And k s to power n minus k. But instead of y here, what should I have? Minus y, yes. So it should be minus y here, raised to the power k. Just right now. Are you part of this group? That's good. That's good. Okay. Let's do an example. Let's try to find x minus y to the power 3. Okay? So for you, you are asking another example, x minus y to the power 3. It's still the same binomials. It's still the same. But what I just did now, here I can just modify the bits. So you will not always have x plus y. No, not always. You will have any term. It could be 2x plus 5y. It could be x minus y, any. But it is an addition. Okay, so this now, this is what? Sum. Okay, how many terms will I have? 4 terms. And it starts from k equal to 0 up to what? 3. And so this is 3, right? K x to power 3 minus k minus y to power what? K. Do you understand what I just wrote now? Yeah. Okay. Am I fast? You can get it. Okay, you can get it. So now we have actually 4 terms. The first will be what? 3, 0. Yes? S to power 3 minus 0. But this is minus y. Eh? Minus y to power what? That's the first step. That's my first step. Okay. My second step. Okay. Let's say we have color. Okay. That's my first step. Okay. My second step. It will be what? 3, 1. S to power 3 minus what? Minus y to power what? 1. 3, 2. S to power what? Minus y to power what? And x to power what? Minus y to power what? So those are the actually the 4 terms. The 4 terms. And once you have the terms, now you can start putting them. 0 choose 3 is what? 1. Yeah, 1. Okay, good. is what? 1. Okay? So the answer will be what? X3. Okay? 1, 2, 3. 1, 2, 3 is what? 3. Okay, 3. So this is 3, and this is S. But don't forget, we have actually minus y to power 1. Minus y to power 1 is what? Minus y. And minus y will multiply this step. So it will be what? Minus here. Huh? Huh? Okay, so here y. So I have minus here. Okay, so we have 3 choose 2. How many 2 choose 3 first? What's the answer? 3. Are you guessing? You sure? What are you doing? Calculator. Okay, this is 3. X minus y square is what? Minus y square.
Y.
Y square. Okay, good. 3 choose 3. 1. X raised to power 3 is 0. 0. And minus y to power 3 is what? Minus. Yes, so it's minus y to power 3. So this minus will be like this. That's the answer. You see? Yeah. Yeah, do the same thing. You could just type an 8 there. Look, I see what you are asking. How to know the number of terms is from the K. K give you the terms. So if you want to know you say 12 now, right? So if I want to know the term 8 there, I just plug K by 8. Yeah. So I will have 12, 8 choose 12. Okay? X to the power 12 minus 8 multiplied by, it's minus y to the raised power. So actually, to not to go the terms, the number of terms, it's just given by k. Okay? So from this formula now, if I ask you what's the third term, just plug here. Those are the terms. Okay, those are the terms. And if you want to know the third term, just take this one and then replace k. And then you have your